Woohoo! It's a great day to be in geometry. I'm Miss Leg Battles, and I'm here today to talk to you about the volume of prisms and cylinders and also of pyramids and cones. Volume is the space that a figure occupies. In other words, what would it take to fill up this geometric solid? Volume is measured in cubic units. For example, could be measured in, say, cubic inches. We write it this way. Sometimes students call that inches cubed, or it could be in cubic centimeters. That's very common, or maybe even cubic feet. We would write it this way. So let's say this is a cubic foot, that it's 1 foot high, that it's 1 foot across, and that it's 1 foot deep. That makes it a cubic. This is 1 cubic foot. Now let's talk about the volume of prisms and cylinders. You know, we talked about that earlier when we talked about cross sections, that the volume of a prism is the area of the base, and this figure is a triangular prism, so the area of the base is illustrated in green, and the height is given in blue. So we find the volume of this prism by finding the area of its triangular base and multiplying by the height. Remember, the height is the distance between the bases. We'll use the same formula or a very similar formula for volume of a cylinder. In the cylinder that's illustrated, we first want to look at the area of the base. The base is shown in green. And we'll multiply that by the height, which is shown in blue. Now, the difference is, for this, the area of the base, since the base is a circle, is actually pi r squared. So the volume would be the area of the base, which since it's a circle is pi r squared, then times the height. So in looking back over these, let's shade both bases for these figures. If you notice on the triangular prism, the bases are parallel and congruent. The height is the distance between them. And then for the cylinder, the bases are circles and they are highlighted in green. They are also parallel and congruent. And the height, which is illustrated in blue, is the distance between those parallel congruent bases. Woohoo! It's a great day to learn some geometry. I'm Miss Leg Battles, and I'm here today to talk to you about volume of pyramids and cones. And we're going to compare those directly with the volume of prisms and pyramids. So I have some great models for us today. Okay, now what is true about these models that's so special for this is that they have the very same height. So I have a rectangular prism. This one is actually a cube. And I have a square pyramid. And look, when I set it on top, you can tell the area of those bases are exactly the same. And the heights are exactly the same. So that's going to help me compare them. Now, I already know to find the volume, it's area of the base times the height for this figure, for this prism. But I know that if this pyramid has the same height and the same area of the base, it's not going to hold as much. and put it inside and there's still space left. So I wonder how much more it holds. Think it holds twice as much? 3 times as much? 4 times as much? 2.5 times as much? I don't know, but we'll find out. So what I'm going to do is I'm going to use this model to check the volume out here with my water. So I'm going to fill it up all the way and put it in my prism. So pyramid with the same area of the base and the same height, I put it in and look, really doesn't hold as much, does it? Let's try again. Let's put a second one in. Oh, what do you think? Will it hold one more? Let's see. And yes, it holds exactly one more. It took 3 of these. So the volume of this pyramid appears to be 1/3 of the volume of the prism with the same area of the base and same height. Now, if that's really true, it'll work for all of them. So look, I have a triangular prism and a triangular pyramid. I'm going to sit it on top so you can see the area of the bases are the same and the heights are exactly the same. So, if everything's good with my formula that I figured out, then this will also hold 3. What do you think? Does that look like it's 1/3? 1, 2, 3. It is 3. And if those work, I wonder if it would work for a cylinder and a cone. Let's see. Okay, gonna show you they have the same height, the same area of the base, and let's see what we have. 1, 2, 3. Perfect. It takes exactly 3. So remember, for a cone and a cylinder with the same area of the base and the same height, this would hold 1/3 as much. So that's where our 1/3 comes from in our formula. It's been great to be with you today. I hate I wasn't in the classroom with you today to show you this model, but I didn't want you to miss out. Have a great day. Now let's summarize what we saw in our experiment. Remember, the volume of a prism is area of the base times the height. Remember, that capital B means area of the base. I have a pyramid that has the same base and the same height. The bases are both squares. They are congruent squares. And the height of each are the same, and they're illustrated in blue. And based on our experiment, it took 3 of those pyramids to fill up that one prism. So the volume of one pyramid would just be 1/3 as much as the volume of the prism. We find that cylinders and cones work pretty much the same way. The volume of a cylinder is the area of the base times the height, but we know for a cylinder the area of the base is the area of a circle. So I've replaced the capital B with pi r squared. The bases are congruent circles as highlighted in green. And the heights are the same as illustrated in blue. So remember, from our experiment, it took 3 of the cones that have the same area of the base and the same height to fill up one cylinder. So our volume of a cone is 1/3 pi r squared h. Now, let's look at some example problems like the ones you'll be working on your homework. First of all, find the volume of the solid. This is a triangular prism. You know, that's very important. Let's write that down. Triangular prism. Remember, it's named by the shape of its base, and this is on its side. So the base are these triangles. This is one of the triangles. Remember, the bases are parallel and congruent. So here's my other base down here. So my formula is area of the base times the height. So for this problem, the base is a triangle. In fact, it's an isosceles right triangle. So it's 1/2 base times height. The base and the height are both 8. Then we're going to multiply that times the height. The height is the distance between the bases, which is 12. So the area of the base, 1/2 times 8, that's going to be 32 times your height, which is 12. So that gives us for the volume 384. Now let's not forget the units. That's going to be in cubic feet. See, my answer for the area of the base, which was this part, is in square feet. Then when I multiply it by the height, which is this, 12 feet, when I multiply square feet times feet, I'm going to get cubic feet. So that's my final answer. Now the next example is a cylinder. We're to find the volume of the cylinder both in terms of pi and rounded to the nearest tenth. Remember, in terms of pi is our exact answer. So my formula for volume of a cylinder is area of the base, which is pi r squared, times the height. So for this problem, it's pi times the radius squared, 7 squared, times the height, which is just 1. So that gives me 49 pi. And this will be measured in cubic inches. So that is my exact answer, 49 pi cubic inches. Now for my rounded off answer. Let me pick up my calculator. I'm going to put in my calculator 49 pi. That's going to be about 153.9. I'm rounding off to the nearest tenth, and of course, that's cubic inches. So this is my rounded off answer. This next problem is a composite figure. Find the volume of the composite figure. That just means it's really two figures in one. So we can divide it up into two separate rectangular prisms. We'll just draw a line right here. Now, we'll let this one be the first one, and we'll let this one up here be the second one. So let's find the volume of the first one. Okay, it's a rectangular prism, so it's length times width times height. So it's 10 this way, it's 11 deep, it's 3 high. So 10 times 11 times 3, that's going to be 330. And of course, that's going to be in cubic centimeters. Now, let's find the volume of the second one. What are the dimensions of the second one? Well, notice it's going to be 11 in this direction. See how it's 11 all the way across? So it's going to be 11 by, and this way is 3 across and 4 high. So times 3 times 4. So that's going to give me a total of 132. So what I want to do now is just add those up. When I add them up, I get 462. That's going to be in cubic centimeters. So in this problem, volume of a composite figure, we just find the volume of the two rectangular prisms and add those together. Now, these are our last two examples. Find the volume of the square pyramid to the nearest tenth. So let's remember, the volume of a pyramid, it's a third what a prism would be with the same base and the same height. So it's 1/3 area of the base times the height. So it's 1/3. Now, the area of the base is this square down here. Okay, how do you find the area of the square? The square looks like this. It's 4 on every side. So I know the area of the square is the side length squared. So I'm going to take that side length 4 and square it. Then times the height, which is the height of the pyramid, which is also 4. Now we need our answer just to the nearest tenth, so you can put all this in your calculator and round to the nearest tenth. Let's see, 64 divided by 3, that's rounding to 21.3, and that's going to be in cubic centimeters. Now our last example is a cone. Now this cone looks different. It's an oblique cone. Let's remember what that is, oblique. But really, there's a principle called Cavaliere's principle that tells us it doesn't matter if it's oblique. If we could envision straightening this up, all the cross sections would still be exactly the same. So we're going to use our very same formula. It's 1/3 area of the base, which is a circle, pi r squared, times the height. So that gives me 1/3 times pi times the radius. Now the radius is given right here to be 2 times 2 squared times the height, which is 3. Now this time we're leaving our answer in terms of pi. Well, this works out nice that the 3 divides into this 3 and leaves us with 1s there. So really all we have is 2 squared times pi, which is 4 pi. And of course the units for this would be cubic meters. I know these examples are going to help you. I'm asking you to practice some that are exactly like them. Woohoo! It has been a great day to learn some geometry.